Well, here we are then with issue 308. And just before I pop to that puzzle, there's an interesting wee thing there about this graphic novel. That looks quite interesting. I might look it up on Amazon, for instance. Graphic novel, Who Killed Professor X? I'll say no more. You can look that up yourself. This week's puzzle. Find the exact value of, it shouts out, maybe just to take up space. And what follows is just a big sum. It's the square of the sines of all the angles from 1 up to 89 degrees. And then it follows with, show your working. Presumably just to stop you using your calculator, just to type it all in and get the answer. Well, what have we got? There's the sum written out. I've put a slightly bigger space in the middle, but actually I should have made it bigger because I want to put more in there than I've left room for. So how would you do this without a calculator? Well, sine squareds should ring a bell, because I can get answers to sine squareds if I've got cos squares, because I know that sine squared of any angle plus cos squared of any angle comes to 1. I've got sine squareds, but I've no cos's. But then there's a connection between sine and cos. And not just this connection between sine and cos. Sine squared plus cos squared makes 1. There's a connection between them that's illustrated best in its graph. Here. They don't need to be in degrees, but since the question's in degrees, I'll just pop degrees there so I can just put a 90 here. And of course that's x. As x increases from 0 to 90, what happens? The sine climbs through the values going from 0 up to 1. There's 1 at the top. The cosine decreases, but climbs through the same values in reverse. Go forward 1 degree, the cosine goes back 1 degree from 90 to arrive at the same value. As the sine climbs up its graph, the cosine matches it exactly by climbing up its graph in reverse from 90. The other connection would be the sine of x is equal to the cosine of its complement, 90 minus x. Let's pop them into degrees because it was degrees in the question. Which means you could replace these with the cosines. So this one at the end could be written as cos squared of 90 minus that 1 degrees. Look, that matches. I could replace that with cos squared 2 degrees. Now they're all going to match in pairs until of course you get to that sine squared of 45. There'll be no partner for that. But there'll be a partner for sine squared of 46. And there'll be a partner for sine squared of 44. Oh, I did just manage to squeeze them in. So sine squared of 1 up to 44 will have partners over here, because this would then turn into cos squared of 46 away is 44 degrees. Would have exact partners over here, and there are 44 of them. So there's 44 lots of sine squared plus cos squared. You've got 44 lots of that, plus this odd one, this odd sine squared 45. Better not leave these without their heads. I'll put a wee A or something in there. Oh, sine squared plus cos squared is 1, so that comes to 44. The sine of 45 is 1 upon root 2. You remember that from your 45 degree triangle. It's half a square. The simplest sides for a square are 1 and 1, and then using Pythagoras gives you root 2. So the sine and the cosine are both 1 over root 2. Unless you press the buttons in the calculator, and you'll have root 2 upon 2 because it will automatically rationalise the denominator. Squaring that gives you the square of the top's 1, the square of the bottom takes you back to 2. So that's 44.5. The answer to this sum is 44.5, or if you like, 44.5.